Hi, let's talk a little bit today about compilers. This video is designed for someone who is very new to the world of programming. It is not going to cover all the pitfalls or any deep technical understanding of what a compiler is. This is going to be a surface level understanding so that someone very new to programming will be able to understand what a compiler is, why we need it, and a little bit about the differences between an interpreted versus a compiled language. So this right here is a computer program. This one's written in the C language and it's very simple. This is essentially the most important line. There's not very much here though. It's going to say hello world to the user. It's going to print it out, a little dash, and then this %d means it's going to send a number, which is a. And if we look up here, if you remember basic algebra, a variable, you can use a letter as a variable, like x equals 23 plus 4. What is x? That's kind of similar to what we're doing here. We're setting the variable a to equal 2 plus 6. So whatever 2 plus 6 is, the computer will do some math, it'll figure that out, it'll assign it to a, and then it will give it to the user. Now, in the old world of computers, and by old I mean originally, when we were making our very first computers during World War II, our first digital computers at least, we made a computer called the ENIAC, which was massive and took up an entire warehouse. We used it for calculating artillery, angles, and a whole bunch of stuff like that. We used it to try to break some codes. We did a lot of things with that computer. But in order to interact with and program that computer, we had a bunch of cables that we would plug in. And those cables represented a 1 if it was plugged in, or a 0 if it wasn't plugged in. Think of it like a light switch on and off, right? So you got to program one very simple math problem into this entire machine by plugging in all of these little 1s and 0s to do complicated math. And as you can imagine, that was a little difficult. I don't know about you, but I don't think in 1s and 0s. Personally, I think in English. So down the line, in the later 40s, the 50s, the 60s, the 70s, the 80s, as we moved throughout that entire time period, people were coming up with new ways to interact with and program computers. Most of them were different kinds of programming languages. C, which is what we see here, is one of those programming languages. But the purpose of a programming language is to make it easier for us to understand what we're telling the computer. Now, obviously, the computer still doesn't understand this. This isn't the 1s and 0s and machine code, the language that the computer speaks. This is an English representation of some of that to make it easier for us to write down instructions. Like 2 plus 2 would be really difficult to do with a bunch of cables if you're just trying to. That's very simple math, but it's kind of complicated to do if you're just doing it with 0s and 1s. It takes a lot of work and you got to pay a lot of attention. So when we made these computer languages, we also had to make a program in the middle called a compiler. You can think of a compiler a little bit like a translator. If you're translating between, say, English and French, you can give your document in English to a translator. They can read through that whole document and write it all down in Spanish so it means the same thing. Hand it to a Spanish speaker and they can read through it, and then they have that whole document, like the Bible. We've translated the Bible into just so many different languages throughout the world. And once the Bible's been translated into that language, or whatever document you have, it's in that language. The person can have it on their bookshelf and they can always keep reading through it. They don't need the translator to go through it again. Whereas with something like an interpreted language, which would be something like Python, every time you run the program, so this would do more or less the same thing, it's just written in a different language, right? We're going to still print hello world and we're going to do 2 plus 2. Every single time you run it, so in this case, every time you run this play button, the computer has to, translate it into something the computer hears every single time you run it. With a compiled language like C or C++, C#, even Java, The computer doesn't need to have it translated every time. You translate it once, you compile it once. That's the word that I'm using interchangeably with translate here, though. The kind of translation that happens in Python in an interpreted language is a little different than the one that would happen in something like C, but it compiles it together into ones and zeros machine code that the computer can then understand. It's like going English to Spanish. We're going human brain to computer brain. So we build these languages, and then the compiler understands what int main means. It understands what this include statement means. It understands what a equals 2 plus 6 and what to do. It understands how to translate that into something the computer can then do. So I'm going to give you some examples here real quick. So let's get into our hello folder here. So hello.c, if I tried to just run that, so this is how you run a program from the command line in Bash, which is it's kind of like command prompt on Windows. Mac OS has this, Android has this, Linux has Bash. Hello.c, if we just tried to run it that way, it's going to say, you don't have permission to run that. So I'm going to run that as an administrator. Type in my password. And it says command not found. I have no idea what hello.c even is. This is a file, right? Now, so we need to compile it or translate it. But from now on, I'm going to start using the word compile. We're going to compile this into machine code. So we're going to use a compiler called the GNU-C compiler, or GCC. There's a lot of different C compilers out there. This one's very common because it's free. It's been out for a very long time. Compilers used to be very expensive, but as time's moved on, compilers have become, in many cases, free, though not all compilers are free in the modern world. So we're going to compile this, and we're going to say we want our output to be hello. We're just going to name it hello, and our input file is hello.c, right? We're taking this file, and we're going to translate it into something to run. We're going to hit enter. Very quick on that file, right? And now it's translated. You'd notice up here it showed up. If we try to look at this file, it says, this is not something that I understand. I can't show this. It's not any text that my computer knows. But I'm going to try to open it anyway. And you're going to see it's a bunch of gobbledygook. There's a little bit of English in here. MH, execute, header, main, printf. There's some things that might, look a little bit familiar. But more or less, this is almost impossible for a human to work with. Though there are ways for you to open this in special file formats and work on it. This is what's called a binary file. So this is like your .exe. So we're going to go ahead and run that. Remember how we run it? The /hello, right? Which is different than our hello.c. We're going to push enter. Hello world -8. See, it did that 6 plus 2 and it put it in here and everything else. So I can run that again and again and again and again and again, and it's going to run forever. But let's say we want to make a change. Okay? Well, actually, let's not make a change. Let's look at our Python program very briefly so we can see we can run that over and over and over again. So our Python program here, we're going to push our run button. And you'll see it did a little bit of stuff, and it ran it, right? Every time I push the play button, it has to interpret it every single time. And this here isn't showing the interpret. It's showing it. It's showing what this play button's doing in the background, and then it's running it. And now here, it looks like it's running pretty similarly in speed to our little hello program here, right? So this hello, I can do 2 plus 2, and then I can just change this to say, let's say 2 plus 5, and I can run it, and it'll automatically update to 7, which is the proper math. But if I go over here to our hello program, and I change this to, say, a 2, right, and I save that, and I try to run hello, it still says 8 because we haven't compiled it. We haven't run that translation step. So if I make a change here, it's not necessarily here, but on an interpreted language, if I make the change in the file, it's in the program next time it runs. So in order to see this change, I would have to compile it again. And then if I run hello now we'll see the math updates. And that's a lot of how that works. So why not just use an interpreted language all the time? Well, unfortunately, having to do that compiling, or in this case, it's interpreting step. Think of someone standing in the middle, actively in the middle of a conversation, translating from one language to the other sentence by sentence for the computer. That's similar to how an interpreted language works. And interpreted languages are things like Python, BASIC. There's tons of them out there. It has to stand in the middle, whereas over here, once you've compiled it, it's ready to go. In these short, simple programs, that doesn't make much of a difference. But if you're, say, doing a lot of complicated math or a very large program, like, say, the Linux kernel, for example, which is over 5 million lines of code, I think last time I checked it was closer to 10 now, that just to compile, just the GCC step on that, on a really good computer, you're looking at 15 to 20 minutes. And on a mediocre computer, you're looking at 1 to 6 hours. So every time, if you had to do that every time you wanted to run it, it'd be really slow and hard to use your computer. And Windows has a kernel, Mac OS has a kernel, tons of software exists that's written in C because they want it to be fast, or that's written in C++ or Java or C# because compiled languages can be faster. All right, I took a brief cut and we're back. I wanted to show you why interpreted languages and compiled languages, one of the many reasons they still both exist. So this is a simple, let me change this. This is two simple programs that do essentially the same thing, finding some factorials. They're written in the same process. They should work mostly the same. And what we're going to see here is the speed difference between our Python, or our interpreted program, and our C program, which is compiled, right? What we're going to do is we're going to start a counter. We're just going to loop through the factorials. We're going to end it, and then we're going to print them out. And it's doing that same thing in both languages. If you want to pause it and take a look through the C code, please go ahead. But we're going to start here. The first thing we're going to do is we're going to run our sum.py program, right? So we're going to go py. Oh, that's right. Python 3 sum.py. And this is going to run, and it's going to take a minute. So I'm starting it. The program is currently running. Remember, it's going to go through all of this stuff, and it's not going to print it until it's found it's found the number that it's looking for. It's going to be the 500 millionth factorial. There you go. It took about 14.9 seconds, just under 15 seconds to get this number. That's quite a long time, but that was a lot of math. It was certainly faster than if I were to do it with paper. Now, let's open another terminal here. Let's go into sum-c, which is this file over here. We're going to compile it. Right, we're going to make a file called sum out of sum.c, and then we're going to run it. We're going to run sum. Bam. Same number, same process, less than half a second versus our Python program, which was nearly 15 seconds. So that interpreting, that translating between two people, or however you want to think about it in your mind, takes a lot more time than translating the entire document, compiling it into something the computer runs, and just running it. And it adds up. Now, if you're just doing simple programs, it doesn't matter at all. Well, it does matter. There is an impact. But as we saw with our Hello World demonstration, it doesn't typically matter enough for the user to even notice. So there are things that Python's really good at. There's things that C are really good at. There's things that you want to use a compiled language for and things that you don't. So if NASA's, say, calculating rocket trajectories and orbital simulations, it's not uncommon for them to use something like C or Fortran or another compiled language, simply because you just have to put the instructions together and then you run them. If you notice, compiling our C program, right, we're just going to compile this real quick, was a lot faster. If I compile it and then run it, both of those steps together are a lot faster than the one running step of our Python program. See, this is still going, and we had already run and completed our C program by now. So, if you're dealing with a lot of complicated math, Python can be okay, and C can be a lot better sometimes. It depends on what you're doing. And there we go. I see a little bit shorter that time, but still took a little while, 15 seconds. You'll see this is a little more consistent because it's just going so fast that all the additional decimals disappear. But that's just a demonstration of one of the many reasons why compiled languages still exist when we have the technology to just have the computer understand it real time. It really depends on the languages you're in. But that's all I wanted to share with you today. I hope that you have a little bit better of an understanding of what a compiler is and what an interpreter is. There's a lot more that you can find yourself on this topic. I highly recommend Wikipedia. If you go to Wikipedia's page and look for C, or if you go to the Wikibooks Foundation, which is a sister organization to Wikipedia, they have a wonderful C programming textbook that talks about the basics of what a compiler is, almost from the level of someone who doesn't understand anything about programming. And then with Python, I recommend very similar things. There's also an organization, W3 Schools, that has a lot of other courses. Well, I say courses, it's like self-paced, almost Wikipedia level help for how to use these languages. But yeah, that's our basic overview of compilers and interpreters. Have a nice day.